Okay, we're going to be exploring activity 8.1 specifically for this video. What they asked us to do is set up a series circuit. I got a power supply set at 6 volts, and it's going to come through in this angle with all the hardware set up. And what the question that we're exploring with this activity is going to be involving this idea of an island. And so we have a capacitor here and a capacitor here, but in between those we have two resistors. And the resistors are lamps that we should see the evidence of current if these lamps light up. Our conventional theory so far tells us that if charge doesn't flow through here and charge doesn't flow through here, that these would be cut off or isolated and not light up. So let's investigate. This is 8.1. We'll go ahead and close this circuit now. We'll watch the bulbs. 3, 2, 1. Okay, so I guess that's what needs explaining for this activity, is that we did see the two bulbs light up even though they were isolated or cut off. And so the first part of this was asking us in question number 2, do the bulbs light? Yes, they do. They do light. And when are they the brightest? And I would say that they're the brightest right after connection, and then they dim out. Sort of like what happened when we were just investigating a lamp and a capacitor in series. Question number 3 says if the bulbs did light, then we should use a compass to compare directions and magnitudes. So what this question is asking us to understand is the current on the direction of the current on the outside equivalent to the direction of the current on the inside of the island? So in order to do that, we're first going to have to check our voltage on these capacitors to make sure they're charged. And you can see on the ohm meter that says about 2.8. And on this capacitor over here, it also says 2.8. The capacitors are identical voltage to each other. And also, 2.8 plus 2.8 makes almost 6 volts. So there's something to explore there as well. I'm going to discharge these capacitors. I've drawn a wire across the two leads. Now that they're discharged, we're going to focus on the compass and see if we can see a deflection now. So we're charging in 3, 2, 1, charge. And in that case, we see a deflection counterclockwise. Not a large deflection, just a small deflection counterclockwise. Go ahead and discharge these one more time. We'll move the compass now within the island, and we'll recharge in 3, 2, 1. Same result, same direction, same magnitude. Now we'll move the compass to our third location, which will be on the outside of the other capacitor. In 3, 2, 1. Again, counterclockwise, same magnitude. So that answers question number 3, is that all of the compass directions and magnitudes are identical. There's no reverse of current between the two capacitors. All right. The next question asks us to explain this with the battery-driven charge flow model versus what could possibly be happening here. And we know that there's something that happens when we see a light bulb light up, and that is that there has to be a charge that's driven through the pressure differential to light that up. Now, if charge is not flowing through the capacitors, then how can charge be moving through the resistance of this bulb, causing it to light up? And so we're going to have to consider that a little bit and figure out what's going on here. And that's going to take place in the next part of the laboratory.